Hello friends. In today's class we are going to solve question related with banker's algorithm. Welcome here, and this is gate 1996 question. A computer system uses banker's algorithm to deal with deadlocks. Its current state is shown in the table below, where P0, P1 and P2 are processes and R0, R1, R2 are resource type. Okay, so maximum need here in this given here is 412, 151, and the need matrix is given, no need to calculate. Allocation is 102, 031 and 102. Show that the system can be in this state. Okay, now its availability is a 2, 2 and 0, and here we can satisfy which request we can 2, 2, 0. Allocation is need is here in this case is 1, 2, 3. Maximum need, so this is maximum need. The need matrix I have to calculate. So here need matrix will look like this. Here 4 minus 1 is 3, 1 minus 0 is this, 2 minus 2 is 0. 1 minus 0 is 1, 5 minus 3 is 2, and 1 minus 1 is 0. And here 1 minus 1 is 0, and 2 minus 0 is 2, and 3 minus 2 is 1. So this is my requirement. This is the need matrix. And here I can go with, I can satisfy the request of P1 because it is 220 and I required 120. Now what it will do, it will relinquish the control of your the allocated one, that is 031. It will relinquish 031. That will left with 2, 5 and 1. Now, can I satisfy any other request 2, 5 and 1? So yes, we can go with your P2, and here we can satisfy 2, 5 and 1 is there, so we can satisfy this request. It has been 251 is the current resource, and it has been allocated with 102 to 102, and this is 3 and this is 5 and this is 353, and definitely with 353 we can satisfy the request of 310. Okay, so P1, P2 and P0 is the safe state in this. So this is this show the system can be in this state. Yes, system can be in this state. It is still safe. What will system do? Do on a request from P0 of 1 unit of the resource type. So 1 unit of resource type it is requesting, and resource type R1. Okay, so right now it is having 0. So now this will become what? This will become 0 plus 1, and here need will change. Need will change means it will become 4, it will become 3, and then it will become 0, and it will become 0. This will not change, and this will may remain as 1, 2, 0, and 1, 2, 3. 1, 2, 3 means it will become 0, 2, 1. This is the new need matrix, and availability is what? Now 2, 1, 0 is your availability. Available. Okay, now can I say satisfy any request in this case? So now here this is okay, but here 2, 1, 2, 0, this previously P1 was satisfied here because it was 120 and the availability was 220, but here now availability is 210, and here I can't even satisfy both the request in this case. Okay, so you cannot satisfy any request if one more resource is allocated to P0. Any request will not be satisfied. Okay, if one more resource allocated to P0. Okay, what will system do on the request of P0 1 unit? So I think this request should be denied, because after that no progress can be made. So until the resource is available, so the system should deny the request of one more resource. because that will not make any progress in that case. 2017 question. A tape system has maximum 9 tape drives. So there is a 9 tape drives are there, and the current allocation of the maximum requirement, current allocation and the maximum requirement of tape drive is given here. P1 is currently 3, maximum is 7, need is 4, 6.1 need is 5, 5.3 need is 2. Now, can I have a, if I have a 9 tape drives, okay, 9 tape drives are there, and currently allocation system has total 9 tape drives, and currently how many allocated? 7 allocated. 2 is there. 2 left, because see 9 total tape drives, and this current allocation 7 is allocated. 7 allocated, right? And if you 7 allocated, then 9 minus 7, only 2 tape drive left. Correct? Now, so can I satisfy any request? I can satisfy this request. 2 P3 will be one sequence that I can complete, and it will release what? It will release 3, and that will make it total sequence as total allocation as 5. 5 can satisfy this 4 and 3. 4 and P1 and P2, both I can satisfy with this. Suppose I go with P1, then it will release the resource 3. 5 plus 3, 8, and with the 8 I can definitely satisfy P2. So P2. Okay, so yeah, it is safe. Okay, safe and deadlocked, safe and not deadlocked, safe and not deadlocked. Okay, so that answer here in this case, it is safe. And current situation, if we have 2 tape drive, then safe and not deadlocked. Here, if I go by that option, that what system will do, the system will be in the safe state. Okay, it is in safe state, but it is now deadlocked. If I go by that option, the previous option, so it is safe and not deadlocked. Look at here, 2018 question, and in a system there are 3 types of resource: E, F, and G, and P0, P2. 4 processes are there. At the outset, the process have declared their maximum resource requirement using the matrix max. Yes, and for example, that is okay. Instance of the matrix. The number of instance resource allocated to the various process at any given state is named as allocation. So max and there an allocation is there. Consider a state of a system. Consider a state of the system with the allocation matrix given below, and in which 3 instance of E, in which 3 instance of E and 3 instance of F are the only resource available. The 3 instance of E is 3. I think E, F, G is there. E, F, G, and 3, 3, 0 is by this. From the perspective of deadlock avoidance, which of the following is true? Okay. So I need first here in this case is a need matrix, and let me just draw the need matrix. So 4 minus 4 P0, 4 minus 1 is 3, 3 minus 0 is 3, and 1 minus 1 is 0. This is for what? This is for P0. Okay, then 2 minus 1 is 1, 1 minus 1 is 0, and 4 minus 2 is 2, that is P1. Then 1 minus 1 is 0, 3 minus 0 is 3, and 3 minus 3 is 0, P2. And then is 5 minus 2 is 3, 4 minus 0 is 4, and 1 minus 0 is 1, that is your P3. This is my need matrix. Okay, so now can I satisfy any request? Yes, a request can be satisfied here, and that request can be here in this case is P0. Okay, and P0, because 330 is exactly there, 330, even P2 can be also satisfied with this 030. 330 P1 cannot be satisfied with 330 can be satisfied, and it's been allocated with what? P1, P0 is satisfied. So 101 it is allocated with. So now we are left with 101, and now we are left with 431. Which request can be satisfied? I think we can go with P2 here. Okay, 431, P2 is 030, so 030 definitely satisfied. P2 and okay, P2 is having 103, so now it will become 103, and that will become 5 3 4. With 5 3 4, I think I can satisfy 5. I can only satisfy P0 in this case. 5 3 4. Okay, now no. With 5 3 4, we can satisfy P0 is already done. We can satisfy what we can satisfy with 5 3 4. I think we can satisfy P1. There is a 1, there is a 0, and there is a 2. So P1 can be satisfied. P3 cannot be satisfied because here it is 4. So now it will release the resource of P1. What is P1? 1 0 2, 1 0 and 2. P1 is having 1 1. P1 is having 1 1 2. Sorry, 1 1 2. 1 1 2. So that will become 6 4 and this 6 6 4 6 can satisfy request, that is your P0 P1. I can say P3. Okay, the system is in safe state and but would be safe if one more instance of F are available. The system is not in the safe state but would be available one more instance of F is available. The system is not in the safe state. Okay, what I got here is I find the system is in the safe state with the safe sequence P0 P2 P1 and P3. Okay, so the very simple question, I think 330 is there and immediately I can satisfy the request of P0. Okay, so answer here in this case is A. That's all for this discussion. Thank you.